Hi everybody, hopefully you can hear me. If not, you're looking at me point at this sign and hopefully getting your sound up and running. This is the lesson on Chapter 7, Section 6, Part 1 out of the Geometry Chapter 7 Study Guide. This one is on the trigonometry ratios of sine and cosine. Now, in the previous section we talked about the tangent, and sine and cosine are the other two basic trigonometric functions. It is basically what these are is special names for fractions that are created from putting together two sides of a triangle, one of them in the numerator and one of them in the denominator of a fraction. So for example, if you want to find the sine and you've chosen a reference angle, we'll review what that is. I talked about it in 7.5. What you do is the sine fraction is created by taking the opposite side from that reference angle and putting that on the top of the fraction, and taking the hypotenuse on your right triangle and putting that on the bottom. This fraction, opposite over hypotenuse, is called the sine fraction. Cosine, which is abbreviated COS, of a chosen reference angle A, is going to be a different fraction. That's going to be the fraction that you get when you take the adjacent side of your right triangle, or adjacent side from your reference angle A on your right triangle, and you put that on the top of the fraction. You take the hypotenuse side and you put that on the bottom of the fraction. So, on this particular triangle, you can see that they've chosen corner A as their reference angle. Here is corner A, so this is their reference angle. You have two choices. You cannot choose the right angle, yet you can choose one of the other two acute angles in your right triangle to be your reference angle. Again, this diagram, they're choosing corner A. So the side that's farthest away from your reference angle, that's going to be called the opposite. I abbreviate that OPP. The longest side is always the hypotenuse. It is also always opposite the 90-degree angle. So that never changes. And then whatever side is left over after you've determined the opposite and the hypotenuse, that side is called the adjacent. So, as I mentioned, sine is going to be opposite over hypotenuse, and cosine is going to be adjacent over hypotenuse. So obviously in this diagram they have specific names. The hypotenuse is CA and the opposite is CB and so on. But normally we just say that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. Okay, so here's an example. They want us to find the sine of angle U. So if our reference angle is this corner up here, this is corner U, that would be right there. So the side opposite from here would be the farthest side away from that corner, which would be 16. So this is our opposite side on our right triangle if corner U is the angle we're referencing. This side right here is the longest side. It's also the side across from the 90-degree angle. That side will always be our hypotenuse no matter what our reference angle is. And then whatever side is left over, that will be our adjacent. So this must be our adjacent. Adjacent means next to, and you can see here that this side is one of the two sides next to corner U, reference angle U. So that makes sense. So if I want to find the sine of reference angle U, that would be a fraction where the top is the opposite side and the bottom is the hypotenuse. So that would be 16 over 34. It's not our final answer because we certainly want to reduce that if we can. That is going to be divisible by 2. And so we get 8/17. Now that is a fully reduced fraction, so we'll keep that as our answer. Now it's actually this question is a little unusual because they actually want us to write the answer in two different ways. They say write each answer as a fraction, which we did, and as a decimal rounded to 4 places. So the way that you would do this is you would take your answer, 8/17, and in your calculator you would type in 8 divided by 17. And then they want us to round this off to 4 places. So that would be 0.470, well, since this is an 8, we'll have to round that up to 6. So 0.4706. Okay, so we have both of our answers for the sine of angle U. Now we're going to change. Now we're going to find the sine of angle W. Now that means that our reference angle is different. So it's no longer U, it's W. So I'm going to start over again with my labeling. Here is corner W. So this is now my reference angle. So I want to identify the sides. As I mentioned, the hypotenuse never changes. The hypotenuse is always going to be the hypotenuse. Now, if our reference angle is down here, W, which side is farthest away from that? Well, that would be this one, the side with length 30. That side farthest away from our reference angle is our opposite side. So, since we have our opposite here and our hypotenuse here, whatever side's left over would be the adjacent, which makes this one, obviously, the adjacent. So now that our reference angle is corner W, opposite over hypotenuse will give us 30 over 34. This is a fraction we can reduce by dividing both the top and the bottom by 2. We get 15/17. That is as much as we can reduce it. It is fully simplified, so that's our fraction answer. Now they would also like a decimal version of this answer. So on my calculator, I'm going to type in 15 divided by 17. So 15/17 as a decimal, okay, would be this. Now, we want to round it off to the 4th decimal place. That's right there, the 3. So we look here, since this is 5 or larger, we were going to round that up to a 4. So 0.8824. Okay, so I have my sine of angle U in both forms, and my sine of angle W in both forms. Now let's work on cosine. Cosine is similar to sine, but it's a different fraction. Remember, when we give these trig functions names, they are just representing a different kind of fraction. Tangent is the fraction that we make when we have the opposite side on the top and the adjacent side on the bottom. Sine has the opposite on the top and the hypotenuse on the bottom, and cosine has the adjacent on the top in the numerator and the hypotenuse in the denominator. So, first, I'm going to try to find the cosine of reference angle S. So if this is my triangle, this is S right here, so this corner would be my reference angle. The opposite side is farthest away from this corner, which would be down here then. That's my opposite. The hypotenuse is the longest side. It's also going to always be across from your 90-degree angle, so that would be here. And then whatever side is left over is your adjacent. The cosine of this angle, cosine is the fraction of the adjacent side over the hypotenuse side. So that would be, on this particular reference corner with these names, it would be 45/53. Now, that is not a reducible fraction. We can't simplify it any further, so that is our answer for the fraction. They also want this answer as an approximated decimal, rounded off to 4 places. So, on my calculator, I'll type in 45 divided by 53. So, rounding this off to 4 places, I'd round off to this position, and I'd look here. If this is 5 or larger, then I'm going to round this up. So my answer for an approximated decimal version of the cosine of s would be 0.8491. All right, that's the cosine of s. Now let's find the cosine of r. When our reference angle changes, some of our numbers do too. So I'm going to erase some of these titles here. The hypotenuse is the one side that always stays the same. The hypotenuse is always going to be the hypotenuse. This time though, when our reference angle is based on corner r, that would be that angle. So the opposite side, being the one farthest away from that angle, would be 45. And the side left over, after you've identified the opposite and hypotenuse, would have to be the adjacent. So there's our adjacent. Cosine of reference angle r is the adjacent over the hypotenuse. So that would be 28 over 53. Again, this is not a fraction that can be reduced. So in terms of its fraction version, that's it. As a decimal, all we have to do is take our calculator and do 28 divided by 53. And we get this. Rounded up to 4 places, we're going to round to this position. Since this is smaller than 5, since this is 0 through 4, we're just going to keep this exactly as it is. So 0.5283 is our decimal approximation. Oops, 5283. There we go. All right, page 2 of our lesson. All right, now, this is very important. This is what the quiz is going to look like for level C. So it's going to be really important that you know how to do these, all right? They have 2 things that they want you to find. On example number 13, they want you to find side A and side B, okay? So what we're going to do first is look at the reference angle and identify the sides. Since 50 degrees seems to be as good a reference angle as we could get, we certainly could calculate this one. If this is 90 and that's 50, this would have to be 40. Since the sum of the interior angles is 180, we could figure that out. But since it's already labeled, let's just go ahead and use that. Opposite from here would be side B. The hypotenuse on this triangle will always be this side, the longest side across from the 90-degree angle. And then whatever side's left over would be the adjacent. Okay, so how do we figure out what side A is? Well, what we're going to do is we're going to create equations, and then we're going to solve those equations. So you never want an equation with 2 things that you don't know in them. For example, if you put the adjacent and the opposite both in the same equation, we'd have A that we don't know and B that we don't know, and we wouldn't be able to solve for anything because there would be too many variables. So we never want to put the adjacent and the opposite, from this example at least, together in the same equation. So we only have 2 other options. We could put these 2 together. We could use the adjacent to try to find that, and then use side 10 as a value to help us calculate. Or we could put these 2 together. We could have the opposite we're trying to find, which is B, and then use the hypotenuse length of 10 to help us calculate. So I'm going to do those one at a time. I'm going to say that the adjacent and the hypotenuse are the two sides that I want to put together to make my fraction. And which fraction would that be if you put together the adjacent and the hypotenuse? Well, it's certainly not tangent. Tangent is opposite and adjacent. It's not sine, because that pairs opposite with hypotenuse. So it must be cosine, adjacent and hypotenuse, yes. So those two sides together exist in the cosine function. So the cosine of some angle, in this case our reference angle is 50, is adjacent over hypotenuse. So the cosine of 50 degrees equals A over 10. This is an equation. It only has one thing that we don't know. So we can solve for that one thing. So just as we did with our tangent equations, what we're going to do is we're going to grab our calculators and we're going to make sure that we are in degree mode. This is 50 degrees. Once we know that we're in degree mode, and every calculator is different, but on this one I would punch in mode, and then I would look to see that I'm actually in degrees. Yes, I am. So I can quit this screen. Once I know I'm in degree mode, I'm going to find my cosine button and find the cosine of 50 degrees. Some calculators, you put the 50 in first and then hit the cosine button, it gives you the answer. On my calculator, I type it in just as you see it on the page, cosine of 50, and then I hit enter. So I get about 0.6427876. I mean, I'm using a lot of decimal places because then my answer is going to be closest to the right answer. If you only use one or two places, you're going to get answers that are might be pretty far away from the correct answer, and your teacher may not mark it right. So make sure you use at least 3 or 4 is even better. 5 is great. Decimal places after your decimal. So just as we did with tangent, what we're going to do is create a proportion. A proportion means you have a fraction on both sides of your equal sign. The way that we create a fraction over here is we just put a bar and a 1 underneath it. Now we're ready to cross multiply. That's how you solve a proportion. Cross multiplying this way and then this way. So 1 times A is what we get when we multiply that way, that's A. And then this decimal times 10 would be 6.427876, right? Multiplying it by 10 moves the decimal over 1 spot. So what they want us to do is round to the nearest tenth for our answer. So I have an A value of about 6.4 for number 13. Now on this same triangle, I can find B. But what I'm going to need to do is combine that with the side that I know. You could certainly use this side length of 6.4 and combine the adjacent and the opposite. You could use tangent there. The other option would be to combine your B with your other known side to make a fraction here. That's what I think I'm going to do. So the fraction I'm going to choose combines the opposite and the hypotenuse. Of our 3 choices, the sine is the only one that does that. So the sine of 50 degrees equals opposite over hypotenuse, which in this example is B, side B, over 10. Alright, so now we use our calculator. The sine of 50 degrees, calculator in degree mode to find this number. So sine of 50 degrees, again your calculator you might have to put in 50 and then hit sine button. Either way you should get about this, 0.766. 0.766. I'm going to go a little further, 0.4 is approximately B divided by 10. So I'm going to do the same thing I did over here. I'm going to create a proportion, so I need a fraction on both sides. You can take any number and make it a fraction by putting a 1 underneath the bar, like that. And then when I cross multiply, that's how you solve proportions. 1 times B is B. And this decimal times 10 is 7.6604. So B rounded to the nearest tenth would be about 7 point. Well, we round around to this position. This is number 5 or bigger, so I'm going to round that up to 7. As you can see, these problems take up a lot of space. So I think what I'm going to do is I'm going to skip over number 14 and then use the rest of the space for number 15. Okay. Number 15, they want us to find side E and side F. So as you can see, they've given us an angle here. So I'll use that as my reference angle. You can't use the 90-degree angle as your reference angle. That doesn't work. So this angle, the farthest side away from that is over here. So that must mean E is my opposite side. The hypotenuse is always the hypotenuse. It is the longest side on the triangle. It's also always opposite in the 90-degree angle. So it would be here, length 12. And then whatever side remains after you've identified the opposite and the hypotenuse, that has to be your adjacent. So, in order to find E, I can't pair that with F, because then I would have an equation where you have an F and an E, and you can't solve for one letter, one variable, and you have two of them in your equation. So, I have two choices. Either I could pair E with 12 and solve that equation, so that would be putting together the opposite side and the hypotenuse side, or I could pair F with 12 and then have an equation where I'm just solving for F. Okay, the adjacent and the hypotenuse. So let's do that first. If I want to solve for F, I'm going to need all the rest to be number values, so I'm going to pair that with 12. And so that would be the adjacent and the hypotenuse, which, as you can see from this other example, is the cosine fraction. Cosine is the name for the fraction when we create the adjacent in the numerator and the hypotenuse in the denominator. So the cosine of 35 degrees equals the adjacent, which is F, over the hypotenuse, which is 12. This side goes into our calculator, right? So I'm going to type in cosine of 35 degrees, enter, and I get approximately 0.819152. I'm going to make a true proportion, so I need two fractions. Making this into a fraction is easy by putting it over 1. Then I'm going to cross multiply. 1 times F is F. And this value times 12 is about 9.8298. So if I round that off to the nearest tenth, as they've directed me to do, my value of F is about 9.8. Now we have a couple options to find E. Either we compare E with this, now that we know it's 9.8, and then solve for E, or we compare E with 12. Because remember, when you create an equation, you only want one thing that you don't know. I'm going to do this one. I'm going to pair E with the 12. That would be pairing the opposite and the hypotenuse. And as you can see, opposite and hypotenuse, that's the name, that's the sign fraction, when we put the opposite in the numerator and the hypotenuse in the denominator. So when I create my equation, I'm going to say the sine of 35 degrees equals opposite over hypotenuse. So that would be E over 12. And again, as you can see, this equation is good. I can solve this because there's only one unknown, only one letter, one variable here. That's good. So I can begin solving by taking my calculator and finding the sine of 35 degrees. Sine of 35 degrees is 0.573576 approximately. And then I want to create a proportion, which means that I have a fraction on one side and a fraction on the other. So this one needs to be turned into a fraction. I can do that by putting it over 1. And then I'll cross multiply. 1 times E is E, and this number times 12 is about 6.8829. Now, if I want to round this off to the nearest tenth, that's the position I want to round off to. I look at the number to the right. If that's 5 or larger, then I round this up. So E is approximately 6.9. Now this one, the perimeter, has a lot of steps to it. Really, basically, you just need to find this length here and this length here and then all the way across. It says that this length is 110. So you can use that along with this triangle to find the length down here and the length right here, and then use this length and the fact that this is a reference angle 45 to find this one right here and this one right here, and then just add all four of those lengths up. Add BC plus DC plus AD plus AB, and you'll have the entire perimeter of the shape.